The increasing demand for electrical energy driven by population growth and urban industrial development has highlighted the environmental impacts of conventional power generation methods that rely on fossil fuels. Solar energy has emerged as a clean, sustainable, and reliable energy for both residential and industrial applications. A single line diagram is a standardized method used to represent the structure and operation of power systems in a simplified form. In our project, this report will present the fundamental concept of SLD and its application in solar powered systems, focusing on power generation, transmission, and distribution.
Moving on to our discussion, I will explain the fundamental concepts of our design and how we generate power. First, we must understand what we are looking at. A single line diagram, or SLD, is a simplified schematic of a three-phase electrical system. Instead of drawing all three phases, we use a single line to represent the circuit. This allows us to easily see the major components and ensures the power distribution is safe and efficient. For this project, we selected solar energy as our primary source. We use solar photovoltaic panels installed in open areas to capture sunlight and convert it directly into DC electricity. We chose solar because it's environmentally friendly, sustainable, and requires minimal maintenance. However, solar panels produce direct current, but our grid and appliance need alternative current. Therefore, we use a three-phase inverter to convert that DC output into a standard 415 AC supply. Immediately after the inverter, we use a step-up transformer. This raises the voltage from 415 volts up to 11 kilovolts. We do this to reduce the current flow during transmission, which minimizes power losses and improves the overall efficiency of the system. Now looking at the detailed single line diagram of our system. Once the voltage is stepped up, we enter the transmission system. The 11 kilovolt power is carried by three-phase transmission lines to the distribution area. A crucial part of this design is protection. As you can see in the diagram, we have incorporated various circuit breakers and isolators. We use VCBs, vacuum circuit breakers, for high voltage protection, ACBs, air circuit breakers, and MCBs, modest gas circuit breakers, are used further down the line. These devices safeguard the system against faults, such as short circuit or overloads, ensuring reliability. If you follow the flow in the figure, we start at solar panels and inverter at the top. We move through the step-up transformer, and the power travels through the transmission line protected by the VCPs. Finally, it reaches the distribution bus bars, which split off into heavy industrial roads and eventually down the residential areas. This layout ensures that power is safely transmitted from the generation point to the final consumers.
Assalamu alaikum. My name is Muhammad Sulaiman, and my matric number is AE240096. And we do also for the discussion for a step down transformer and distribution system. After transmission, the voltage need to be reduced before supplying power to consumer. This is done using the step down transformer, which reduce the voltage 11 kilovolt to 450 voltage to distribution purpose. The power is then delivered through distribution berths, feeders, and service line. A residential consumer usually receive 240 volt signal phase supply, while large buildings and industrial user may receive a three-phase supply. A protective device such as MCB and fuse are used to ensure safety and protect the system from the fault. This table shows the main difference between residential and industrial signal line diagram. Residential SLD are a simple and straightforward, operating at low voltage level such as 214 voltage for a signal line phase and 450 volt for a three-phase supply. They include four components and are mainly used for general purpose lights like lighting and household appliances with minimal uh, monitoring. On the other hand, industrial SLDs are more complex and detailed. They operate at the highest voltage level, such as 11 kilovolt or even 33 kilovolt. Industrial systems include additional components like transform and MCC and relays, and they use advanced monitoring systems such as SCADA for automation. Those systems are designed to hold heavy and specialized industrial load.
Assalamualaikum warahmatullahi wabarakatuh. Name is Muhammad Afi Afizi bin Salim. My number matrix is CE240222. For the model component is a recycle box. Recycle box are used to the main structure base of the model. They represent buildings, equipment, house, and system components such as inverter unit, residential load, and transformer enclosure. Using recycle box promotes sustainability, locals and environment awareness, and the box provides stability and easy arrangement of components on the model box. For the seconds, color A4 paper. Color A4 paper is used to label each component daily, yearly, inverter, transformer, transmission lines, and residential load. It improves visual clarity and presentation quality. Different color to help to distinguish between system stage and make model easy to understand for viewers and examination. Third, for the watercolor, watercolor is applied to highlight the different zones of the power system, improve the aesthetic value of the model. It helps to visually separate generation section, transmission section, distribution and residential area. It's made the model more attractive and engaging during presentation. And last, stick and thread. Wooden stick represent the transmission tower, distribution post. Threads represent the distribution lines and distribution cables. This combination show the how electricity is transferred from the transformer to transformer. The physical structure is overhead power lines. It helps to explain the real power system infrastructure in a simple way. Thanks. For the project model, firstly is a solar panels. The project starts at the solar panels section. Solar panels convert to sunlight into the DC electrical energy. This represents the renewable energy source of the system. At this stage, the power produced is DC, direct current. So the second is inverter, DC to AC converter. The DC power from the solar panels flows to the inverter. The inverter converts DC power into AC power. AC power is necessary because power transmission use AC. Household appliance operates in AC supply. This step prepares the power of the grid system. The third, set up transformer to voltage increase. The AC then enter the step up transformer. The transformer is increase the voltage level. Higher voltage is used to reduce current, minimize power loss during the transmission. This stage represent the preparation for the long distance transmission. Okay. For the transmission line, the high voltage electricity flows through the transmission lines. In the model, stick represent the transmission power. Threads represent the overhead power lines. These sections show how the power is carried over long distance from the site to the distribution area. Fifth, step down transformer, voltage reduction. After the transmission, electricity reached to the step-down transformer. The voltage is reduced to safer and usable level. This is essential before electricity can be supplied to residential area, ensure safety and equipment protection. The last residential load 240 volt supply. The final stage is the residential load. Voltage is stepped down is to 200 volt, suitable to household who use. This represent homes or building consuming electrical energy. Electrical energy is finally used to operate appliances such as lights, fan, and sockets. Thank you.
Assalamualaikum. My name is Narafina binti Mujibur Rahman. My matrix number is AE240027. Right now, I'm going to conclude this presentation. To sum up, single line diagram, are also known as SLD, are one of the most important tools for designing and analyzing electrical power systems. This project explains how solar power single line diagrams are applied in both residential and industrial era. The diagram shows how solar energy is generated, transmitted, and distributed to meet the electricity needs of homes and small industrial users. Solar energy is a great option because it is renewable, sustainable, and also highly energy efficient. Overall, this project helped develop a better understanding of polyphase power system and how renewable energy can be integrated into modern power system. Thank you very much.